Exercise 8A question number 1. The motion of a golf ball is after it is struck by a golfer can be modeled using the equation. When you look at this equation, you can see this is a quadratic equation and it has a maximum because the quadratic coefficient is negative. It is h equals 0.36x minus 0.03 x square. So you can see that this x square coefficient is negative. Then we know that this is going to be a quadratic curve with a maximum. So this height is h given and this length is x. Then the coordinate of this one is x and h. The first question, find the height of the golf when it's struck. So part A1. So when it's struck, the time is 0 and x at that time x is 0. Then when x equals 0, what will happen to the h? 0.36, 0 minus 0.03, 0 square, because x value is 0, answer is 0. So as a coordinate 0, 0. And part 2, at the horizontal distance of 100 meters. So when x equal 100, then h equals 0.36 times 100 minus 0.03 100 square. This is 0.03 and so this is going to be 36 minus 30. So the answer is 10. Answer is 6. So the coordinate is, as a coordinate, it is 10 and 106. So this is, we'll write the answer as here h equals 0 meter, here h equals 6 meter. And part B, use a model to predict the height of the golf ball when it is 200 meters from the golfer. So now when x equals 200, we can apply again 0.36 200 minus 0.03 200 square. The answer you will get minus 48 meters. So as 200 minus 48. So what can you think about? So this is a model. So the model don't feel that there is a ground. The model is going to be like this. So then after 200 meters, so it is according to the picture, because so this level is minus 48 and this is the 0 level. Part C, comment on the validity of this prediction. So we know that we get the height is minus 48. Then we can tell that the model is not valid. What is the model? The model is from here to here or here to here. The model is only here to here because we try to present actual scenario. So then the model has to be focused on the actual scenario. Actual scenario go from here to here. then we can only control by doing this one. We have to give the prediction, the distance range in here. H equal this one, and x is from alpha greater than x greater than beta. So we want to give the domain, or 0, the starting point 0 greater than x greater than or equal to, we want to find this value. How do you find this value? We know that if this is a x-axis, so this is x-axis and this is y-axis, h-axis, and this is the intersection point of with the axis, or this is where, in other way, h equals 0, and this is also this point, h equals 0. So when h equals 0, when we find the root for this x, then they are the values of boundaries. The mode is not valid. The model is not valid for the given distance. This distance x equal to 200 meters as h equal minus 48. The ball is below the ground level. So you want to explain in your words that this idea. How do you find this maximum height here? So we can find this maximum height by finding dh over dt. We know that maximum height means it is a turning point. So it's a stationary point. We know how to find a stationary point. So we want to get dh over dt, and when we make it to 0, we will get okay, we'll find is what is the dh over dt. So dh over dt is going to be 0.36 times 0.003 times 2x. When this is equal to 0, so this is going to be x, then 0.3x divided by 0.006. So in that case, 360 divided by 6. So 60 meter. So the maximum height of this one is 60 meter. So I found the x value. Sorry, I found the x value. So the highest value you will get when the ball flies 60 meters. Then to find the height, we need to substitute this 60 to this equation. Then we will get the maximum height. Question number 2. A stone thrown into a sea from a top of a cliff. So a stone is thrown from so this is the cliff. So a stone is thrown, and the height of the stone above the sea level, h meter. So and this is time, and this is the h. Let's say time axis, the standard coordinate is th. So this height is this time is t, and this is time axis. So h is minus 5t square plus 15t plus 90. Minus 5t square plus 15t plus 90. Now you can see this is a quadratic equation. y equal minus 5x square plus 15x plus 90, and it should have a maximum, and we can see that this is in the this one the parabola. So write down the height of a cliff above the sea level. So write down the height of a cliff above the sea level. So this is the cliff. When t equals 0, we can find the height of the cliff. So when t equals 0, there should be a value for h. So that is the height. So h equal minus 5 times 0 square plus 15 0 plus 90. Answer is 90 meter. So height of the cliff is 90 meter. So when t equals 3, so the next question is find the height of the stone. B. A, when t value is 3. After 3 seconds. After 3 seconds, it should be here somewhere. So that height is minus 5 0 square plus 3 square plus 15 3 plus 90. So this is going to be 9. So this is going to be minus 45 plus 45 plus 90 and 90 meter again. So this is a good question, because when it start also 90 meter, after also it is 90 meter, it means it stay until 3 minutes. No, what will happen? This drawing has to be different. So this is the level, and the model has to be something like this. This is the h, and t equal 3 also it is at 90. When start also t equals 0 also it is 90. For this drawing there are 2 times we will get t equal 90. Sorry, height is 90. That is t equals 0 and t equal 3. When t equal 5, h equal minus 5, 5 square plus 15 times 5 plus 90. So this is going to be 125. This is plus 75 plus 90. That will make 40 meter. So as a coordinate, this is 0, 90, 390, and this is 5, 40. So when it is here 5, somewhere it is here. This can be, it is 5, 40 less than 90. So this height is 90. So part C, when t equal 20, so h is going to be minus 5, 20 square, 15, 20 plus 90. So this is going to be minus 1610 meter. So this is below the sea level. So it's going to be something like this, minus 1610. It is below the sea level. D. So comment on the validity of this prediction. The model is not valid for the given time as the height is below the sea level. Can extend this one as h equal minus 1610. Model is only valid for the t values when h greater than or equal to 0. If you need to find the right t value for that, so the curve is like this. So at h equals 0, if we solve this one using h equals 0, then we will get two t values. One is here, the other one is here. So question number 3, the motion of a basketball as it leaves the player's hand and passes through the net is modeled by using the equation this one. So something like this. This is the player, and the ball is goes to the net. So this is the scenario we have to model, and this is the height of the player, and it could be this one, or because when I glance, find two values x which a basketball is exactly 4 meters above. It means somewhere I can see that okay, or from here it's going to be something like this. Then assume this is the 4 meter level. So then 4 meter, there are two occasions. So in that case, this one is the practical one. So it's going to be something like this. That's how the basketball usually throw. So having this one so that is h equal minus 5t square plus 15t plus 90. First one is A. Write down the I changed the equation. I wrote down the wrong one, and so h is the height from the ground level, and x is the distance from the horizontal distance travel from here, the ball from the player's hand. So this is x-axis, and this is h-axis, and the first question is find the value of x which the basket exactly 4 meters above the ground. So the equation h equal 2 plus 1.1 x minus actually I write to like the other way around, h equal minus 0.1 x square plus 1.1 x plus 2. So when h equal 4, minus 0.1 x square plus 1.1 x plus 2 equal 4. Then square plus 1.1 x square minus 2. I'll bring this one here. Now we have, this is a quadratic equation, so we have to solve. So x equal minus b minus 1.1 plus or minus b square 1.1 square minus 4 times a minus 0.1 times c is minus 2 divided by 2 times a minus 0.1. So the answer is going to be minus 1.1 plus or minus 0.01 over 0.2, that is minus 1 point plus of 6430 over minus 0.2. So we have two values, x equal 2.30 or x equal 8.70. When x equal 2.3 meters, so this h is 4 meter. This is the going upward journey, and the downward journey we will get that for again at 8.70. Then it is given that the model is valid for the k, so we need to find the k. We know that x is the distance to the ball from the player, and we know the net height is given as h equal 3 centimeter. Then we have to rework this one to find k, because this model is only valid for this model is only valid for when h equal 3. Now we want to find the model validation in terms of x. So we have to rewrite the equation. Minus 0.1 x square plus 1.1 x plus 2 equal when h equal 3. So this is equal to 3. So this is 1.1 x square plus 1.1 x minus 1 equal 0. So I can multiply by 10 this one. This is become minus x square 11x minus 10 equal 0. Actually we can multiply by minus 10x square minus 11x plus 10 equal 0. So I can break this one, x minus 1 to x minus 10 equal 0. So x equal 1 and x equal 10. It means so this is the height level. So this is 1 and this is 10. So we will meet three heights, again 10. Then this k has to be 10. So k has to be 10. So the model is valid. Model is when 0 greater than x greater than 10. The next question is, if c is greater than k is greater than 10, what will happen? So if k greater than 10, so assume somewhere here, a value here, so it may go like this over the net, or it may go under the net. If x greater than k, the model is not valid. Then the model is not valid as the ball will go over or under the net. How it can happen? Why this is go under and above? Because the speed and the direction of the ball has changed. If we need the right turn with the alpha angle, sometime it's going to be a different angle, beta. and with the we need with the alpha angle with the v speed. But if we go with the beta angle with the v1, sometime it can happen. Why this angle and direction will change? Because of the force given by the and the direction given by the player. Question number 4. A car accelerates from rest to 60 mph per hour, mile per hour in 60 seconds. So car. So then t equals 0. Acceleration is 0. V equals 0. And after 10 seconds, it means t equal 10. A equal, it has acceleration. V is 60 miles per hour after 10 seconds. So from here to here, it means this is a story about 0 t greater than 10. So in terms of time, 0 to 10. So we have to, so this model, there's a relationship with distance and time. So when it's raced this car from stationary to the 60 mile per hour, so it has a distance, it goes a distance d and the time t. So that relationship is given by d equal kt square, and k is a constant. Now part A, given t equal 1 and d equal 13.2 meters. Now although it is 60 meter per hour, the relationship with here is meters and seconds. So t equal 1 and d equal 13 point, from d equal kt square, it means 13.2 equal k times t is 1 square, then k we can find out 13.2. Usually when we have unknown constant, that's how we find. So in the information we can see that given that they have information about t and d, or with the other variables to find the constants. Now we can rewrite the right equation, d equal 13.2 t square. So this is the model, and write down the model. Find the distance traveled when the car reached 60 mph. Now distance, the car reached 60 mph when t equal 10. So then we can find that answer is when t equal 10, the car reach to 60 miles per hour. So then d equal 13 point times 10 square, 13.2 times, it means 13.2 times 100, that is 1000 to 3 meters. This car is look like a rocket because for a 10 second it will go 1 kilometer and 1.3 kilometers approximately. And this is B. Write down the range of the value of t which model is valid. So we know that x-axis is the t and y-axis is distance. The time there is no negative values. time can't be negative, then it has to be 0, the starting point 0, and when t equal 10, the model, this journey is finished. I mean, we are modeling only between time 0 to 10. Because of that, this has to be one boundary is 0, the other boundary is 10. So the part B, the model is only valid. Model is only valid for 0 greater t greater 10. So time cannot be negative, hence t greater than or equal to 0, and time cannot be a greater than 10, as the model is set to t equal 10 max. Because this model is set to t equal 10 max, this model is not set to t equal 11 max, because the scenario is given to model is the car reach with the 10 second to that speed. So that's the model. This is enough actually for the answer, but this is for you understand and you can write something more. Question number 5. The model for the motion of the golf ball given in question 1 is only valid when h equal positive. Yes, that's true that the model is given in number 5 is this one, 0.36x minus 0.003x square. Yes, model is only valid. The model is only valid when h greater than or equal to 0. It means 0.36x minus 0.003 x square greater than or equal to 0. If we multiply by this, if we multiply by 1000, I can see that 360 plus 3x square equal greater than or 0. So if I take x out, so 360 minus, actually we can divide by 3 as well. So this is going to be 120x minus x square greater than or equal to 0. Then this is multiplied by 1000 and divide by 3, and when I take out, so this is going to be 120 minus x greater than or equal to 0. So if this is a equation, x equal 120 minus x equals 0, x equals 0, and x equal 120. So this is this kind of equation, and this is x equals 0, and this is 0 0 this value, and this value is going to be 120 0. And when you look at, we know that h value is this height, so h greater than or equal to 0 during this time. So we don't need to do, we can draw from the graph and we can show that inequality, or we can work, you can remember that we work with two different ways. This is x minus 10, so we are taking a number from this side, and then we found x and x minus 2, then Yeah, right. X and 120 minus X, like that. So there are three areas, 0, minus infinity to 0, 0 to this one, and from here to here. But as a sum, we know that we don't need this area, but for your, I revise you that one. So minus infinity x greater than 0, 0 greater than x greater than 10, 10 greater than x greater than infinity. Then if you select any value from this value, this is negative, and this is going to be negative value. So this is positive, positive times negative, negative. So x times 120 minus x, this is negative. And likewise, if you pick up a value from here, this is positive and this is positive, then positive times positive, positive, and this is going to be positive, and this one is going to be negative, and as a result this is negative. Hence this is the only acceptable area. That's how we did the second method. So the model is valid for question number 6. The model for the height of the stone above sea level in the question 2 only valid from the stone is thrown until it's entered. Find the range of value. Yes. So this is the cliff, and then it's throw like this. So this is the sea level. So this is the only area that t is valid for. This is t equals 0, and we want to find this t value, t equal, let's say, alpha. And so at this point the h value is 0 because this is t-axis, this is h-axis. So h is measuring from here. So when t equals 0, h equals 0, we have two answers. One is negative and other one is positive. And but there's no negative times, so then in that case t has to be 0 to up to this one. The equation is h equal minus 5t square plus 15t plus 90, and when h equals 0, this is going to be minus 5t square plus 15t plus 90 equals 0. I can divide by 5. So minus t square, this is 3t plus 1 and 40, 18, 0, and we'll multiply by minus, then t square minus 3t minus 18 equal 0. So this is going to be t minus 6 and t plus 3. So t equal 6 or t equal minus 3. So this is minus 3, 0, and this is going to be 6, 0. This answer mathematically, but when it's come to practical, the t can't be negative. So t can't be negative, and t start from here. So the lower boundary for t, so lower boundary for t is 0, and upper boundary for t is 6. So this is alpha is 6, t equals 6. Hence model is valid for 0 equal t equal 6. If this is x1 and this is h1, so the coordinate of this one is x1, h1. sorry, this is T, so this is going to be T1 and H1. This is for your general knowledge I wrote.